if Vi is equals to 1 minus e power minus alpha t into u of t, where alpha is equals to 1 by r1 c1, then V0 is. Here we know that V0 in case of inverting amplifier R2 divided by R1 parallel with 1 by SC1, which is gain V0 by Vi, that is 2 R1 1 by SC1 divided by R1 plus 1 by SC1. So minus R2 by R1 SC1 R1 plus 1 is the transfer function V0 by Vi. Here we have to find out V0. Minus R2 by R1 SC1 R1 plus 1 Vi of S. Here Vi of S is nothing but 1 by S minus 1 by S plus alpha. Alpha is 1 by R1 C1. So 1 by S minus 1 by S plus 1 by R1 C1, which is equals to which is this one and this one gets cancelled, 1 by S into SC1 R1 plus 1. If we multiply Vi of S, if we substitute this value here, then V0 we will get as in time domain R2 by R1 U of t, which is option B is correct. If 8-bit PCM is changed to L-bit DPCM and voltage range becomes 1/4 of the previous but step size is maintained same, then L is. Here in case of both PCM as well as the DPCM, the step size equation is same. That is, suppose step size I am indicating with the delta. In PCM I am writing it as delta 1 is equals to 2 AM. AM is the peak value of the input signal. The range of the input signal is 2 AM divided by 2 power L. L is 2 power 8, which is in case of PCM the step size. Okay. Now in case of delta 2 DPCM, which is equals to delta 1 PCM, but the voltage range becomes 1/4. That is 2 AM by 2 power 8 equals to 1/4 of the 2 AM divided by 2 power L. This AM gets cancelled. This 2, 2. So 1 by 2 power L plus 1, 2 power 7. L plus 1 is 7. L equals to 6 bits. Hence option B is correct. Your question is, waveform of V0 of t shown in the circuit below is. Here the clock duration is 2 milliseconds, means it attains plus 12 volts first 1 millisecond and next 1 millisecond it takes minus 12 volts. Okay, so suppose if Vi is equals to plus 12 t in between 0 to 1 millisecond. This is the first cycle. Minus 12 rows, it is in between 1 millisecond to 2 millisecond. Similarly, it repeats for 3 to 4, 4 to 5. In that manner, it is going to repeat. So if Vi equals to plus 12 means the transistor is going to turn on. So transistor is in on situation. This is 0.1 microfarad. So V0 is nothing but voltage across the capacitor. So in the steady state position, the capacitor acts as a open circuit. Open circuit means in the steady state position, Vc of t is nothing but 12 divided by 12.1 K into 0.1 K, which is equals to 0.1 volt. 0.1 volt means 0 to 1 millisecond. The amplitude of the output voltage is 0.1 volt, which is a constant as this one. Okay. Now if Vi is minus 12 volts, then the transistor turns off, means it acts as a open circuit. So the Vc of t is nothing but 12 into 1 minus e power minus t by Rc. Here Rc is the time constant, that is 12 into 10 power 3 into 0.1 into 10 power minus 6, which is 1.2 milliseconds here. But the duration of the input waveform, which is having a minus 12 volts, is only for 1 millisecond, but the time constant is 1.2 milliseconds, means it needs more time to charge towards the minus 12. So after 1 millisecond, it's going to attain again plus 12. When plus 12 means the output is going to be 0.1 again. Hence the duration of the charging period of the output waveform is only for 1 millisecond, that is 1 to 2 milliseconds. Hence output waveform is C. Option C is correct. Two normal communication systems have the same frequency distribution function, but the standard deviation of the first is twice that of the second communication system. What is the maximum frequency of the first communication system to the second? Here the frequency distribution function f is given as sigma 2 pi e power x minus mu 2 sigma square. So f1 is first communication system, sigma 1 2 pi. It is the maximum. So this is x minus mu by 2 sigma whole square. The f1 attains maximum frequency whenever x equals to mu, that is 1 by 2 pi under root into sigma 1. Similarly, f2 root 2 pi sigma 2. We know that sigma 1 is 2 sigma 2 from the given data itself. So f2 is nothing but root 2 pi. Sigma 2 is nothing but sigma 1 divided by 2, that is 2f1. So f1 by f2 is the frequency ratio, that is 0.25. Hence option B is correct.